What's up, exotic pet fans? It's Miss Sorensen here. We are on Unit 2, Probability. It's one of my favorite units. I wish we got to do it in person to do some gambling together, but it is what it is. So let's get started on video 11, Gambling Introduction. Let's give an example of a probability that's impossible. For me, I'd say that would be rolling a 7 on a 6-sided die. Right, there is no 7 on a 6-sided die, so that is absolutely impossible. Give an example of a probability that's a 1 in 6 chance. Well, how about rolling a 5 on a 6-sided die? There is 1 5 out of the 6 numbers, so you have a 1 in 6 chance of doing that. All right, how about giving a probability that something is certain? Well, how about the probability of picking a red or black card out of a deck of cards that's only red and black cards? Well, you can pick a red one or you can pick a black one. So without a doubt, when you pick a card, you're absolutely going to get a red or a black one 100% of the time. All right, so let's go ahead and let's go down to kind of this table here and say that if we are 100% certain that something is going to happen, we would say it has a probability of 1. If something is impossible, it will never happen, it will be a probability of 0. And if there's an even chance, like a 50-50 chance, we would say that the probability is 1/2. Okay, notice how I'm doing probabilities with fractions, and it goes from 0 all the way up to 1. Okay, what's the probability that you win the Powerball? Okay, if you don't know much about the Powerball, you play 1, 2, 3, 4, 5 numbers, and then you've got a Powerball number. And you have to get an exact match to win the entire Powerball. Certainly, you can get prizes for getting the Powerball right, or 2 of the numbers right, etc. And how much does it cost? A whopping $2. Now, what's the probability of winning in Powerball and getting all the correct numbers of getting the big jackpot? Well, that probability is roughly 1 in 175 million. What does that really mean? It means that if there were 175 million tickets sold, one of them would be the winner. All right. How can we visualize that? Because we don't really understand what 175 million is. I mean, I know it's a big number, but here's what I want you to think about. I want you to think about dollar bills laid out right next to each other. So here's your dollar bill. Here's another dollar bill. Okay, here's another dollar bill. I want you to think about laying out dollar bills. And I want you to do it all the way around the country. I want you to start in Maine. Okay. And then I want you to go all the way across the country. You're going dollar bill after dollar bill after dollar bill after dollar bill, all the way going to Florida, up the East Coast. There you go. So you're putting tons and tons of dollar bills back to back to back on that kind of that road that I just drew. And guess what? You do it one more time. You go around that one more time. Okay? The probability of winning the Powerball is equivalent to you going on that path and picking up the correct dollar bill. And there's only one winner. That is how slim your chances of winning really is. It's really, really small. Okay, let's answer a few questions here. The probability of winning the Powerball, and this is a little bit less rounded than what we were saying before, is 1 in 175,223,510. What's the probability if you buy 5 different sets of numbers? Well, you know, a family member might say to you, hey, if I buy 5 more tickets, then I have 5 times greater chance of winning, or my odds are 5 times better. Is that true? Well, let's look at it. So our denominator is going to be the total odds here, 175, 223, 510. Instead of having 1 ticket out of those 175 million, you actually now have 5 tickets. Okay, so that's your probability. And is that actually 5 times more than 1 over 175,233,510? Yeah, it actually is 5 times more. So your odds are 5 times better. But guess what? Your odds are still terrible. Even though you've increased your odds by 5 times better, your odds are still absolutely terrible. All right, number 2. The probability of being struck by lightning is 1 in 6,250. How many times more likely are you to be struck by lightning than win the Powerball? Well, let's look. I'm going to have my 175,233,510. And I'm going to put a X here. And I'm going to do 1 over 6,250. What am I saying here? I'm saying that my probability of winning the lottery times what number is going to give me this. Because it says how many times more likely are you to be struck by lightning. So I'm trying to figure out what this number is because I want this times this to get me how many times more likely I am to be struck by lightning. All right, well, how do I do that mathematically? All I would do is multiply by 175 million on both sides. Okay, so I'm going to multiply by 175,233,510. And I have to do that over here as well, 175,233,510. Okay, here we've got to cancel. So I'm just simply left with X equals, and this ends up being 175,233,510 divided by 6,250. And that gives me 28,035.8. And that's how many times more likely I am to be struck by lightning than win the Powerball, which is crazy. Crazy that you are way more likely to get struck by lightning than win the Powerball. Now, I want you to kind of pause here and say, how can I do my homework a lot faster than what Ms. Sorensen did? Well, I'm going to ask you a bunch of these questions, and really all you ultimately have to do is take your odds of 175 million and then divide them by the odds that I give you in the problem. You don't have to go through the whole process that I just went through, although it's nice that you understand it. All right, let's talk a little bit about the gambler's fallacy. So the gambler's fallacy really kind of has a perfect example, and that example happened on August 18th in 1913. In this situation, the ball of roulette wheel at Le Grand Casino of Monte Carlo landed on black 26 consecutive times. Now, if you know what a roulette wheel looks like, it's majority black and red. And so for it to land on black 26 times in a row, that is absolutely unbelievable that that happened. During the streak, a betting frenzy ensued as a growing crowd staked increasingly large amounts on red. Right? You would think if there's nearly a 50-50 odds of getting black and a 50-50 odds of getting red, people believed that the ball was due to land on red. And what happened was it ended up being black, and they lost, and the casino reaped a large reward thanks to the gambler's fallacy. So what is the gambler's fallacy? It's the false belief that a certain event is going to happen because it is due to happen. It's also the false idea that two things are related when really they are not. Okay? Let's do a few more examples of the gambler's fallacy to get you a better idea. Okay. Have you ever gotten sick after eating a certain restaurant and then said to yourself, I'll never eat at that restaurant again? And you make the connection that you got sick because you ate at that restaurant. Well, you're making a connection that may not possibly be there. You're saying that two events are related when in fact they may not be. Have you ever done this one? Have you ever not studied for a test and then did really well and said, oh, I better not study for a test ever again? You're making the false connection that you did well on the test because you didn't study, when in fact, the reason why you did well on the test might have been something totally different, like you ate breakfast that morning, or you actually listened in class, or you did the homework, or maybe the test was easy. Okay, here's another idea of gambler's fallacy. You go to the slot machine that hasn't had a jackpot in a while. When you go to casinos, you'll see on the top of the slot machines when the last big win was, when the last jackpot was. And a lot of people go, oh, I got to go to this one because they haven't had a jackpot in, 3 months. I'm due to win. Well, that's not true. Every time you pull that slot machine handle, it's a completely different event. It's not related to if you won the previous time or not. It's completely separate. Here's another example of the gambler's fallacy, betting the same number in a Powerball each time, right? If I'm going to bet a 2 because my sister and I are 2 years, 2 months, 2 weeks, and 2 days apart. I've got 4 people in my family. Mr. Amazon is 96, Tom Brady is number 12, and 23 is my favorite number. I play those over and over again. Why? I say to myself, I didn't win last time with those numbers. I've got a better chance of winning this time. Well, that is a fallacy. That is false. That is not true. You have the same chance of winning every single time, regardless of what you played last time. And the gambler's fallacy is also true for determining if medicine works. People make these false connections between taking something and whether it helped. Let's say you take a medicine and then felt better. Well, did you feel better because you slept a lot that night, or because it was just kind of out of your system, or maybe you ate better that day? Right? People with the gambler's fallacy make connections that are not true. You're making connections that are not true. So if I were to summarize what the gambler's fallacy is, okay, it would be the false idea that two things are connected when they're not. For example, getting sick and eating Taco Bell, doing well on a test and not studying, going to the slot machine that doesn't have a jackpot and winning, betting the same or losing last time with these numbers and winning this time, having medicine and then feeling better, haven't won a hand all night and now I've got to have a payout that's due. Okay, going back here, the fact that it was black, 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 and thinking, oh, well, it must be red. This false idea that the next spin on the roulette had to do with the black ones, the 26 black ones before. All right, that's it for Introduction to Gambling. Hit me back on video 12 when you're ready.